Hey there. So this is 3.13. Go ahead and try the warm-up. And I just want to one more time kind of state how important it is for you guys to be trying the warm-up on your own, not just watching the video and filling it out. It's kind of like what I always tell my middle schoolers who don't do their homework is, you can't show up to the day of a test and expect to be able to do something on your own for the first time when you've never done it on your own before. So for us, the warm-up, each one of these is just making sure that those skills that we already learned, you're still able to do them independently successfully. So go ahead and try the warm-up, and when you're ready, you can go ahead and unpause. Okay, so number 1, we have the limit as x approaches 5. And so on this one, when we just plug in a 5, we get 0 on the top and 0 on the bottom. So we actually have 2 choices on this one. One choice would be to factor the top and hope that the x minus 5 will cancel, which it will. Our other choice is to use L'Hopital's rule. And so I think I'm going to go that way. I'm going to go ahead and do L'Hopital's. So my limit as x approaches 5, and then I'm going to do my derivative of the top, 2x plus 2. Derivative of the bottom is 1. Plug in the 5. 10 plus 2 equals 12. And if you factored, it works out the same. Okay, number 2, our limit as x goes to infinity. So remember, when we have x going to infinity, we want to divide the top and bottom by the highest power of x, which in this case would be x to the 5th. Okay, so I'm going to do that. So I'm going to have 2 plus 3 over x squared minus 8 over x to the 4th minus 12 over x to the 5th. On the bottom, I'll have 3 minus 4 over x cubed plus 1 over x to the 5th. Okay, and then anywhere where we have an x in the denominator, those are all going to have an infinity in the denominator. And remember, when we have a fraction where the denominator gets infinitely large, the fraction gets infinitely small. So each one of those is a 0, and this gives us 2/3. Okay, number 3. I know from looking at this that I'm probably going to want to use that rule that says the limit as x approaches 0 of sine x over x is equal to 1. But remember, we have that stipulation where the x has to match. So here on the top, I have a 2x. On the bottom, I have a 4x. So what I want to do is I actually want to put a 2 on the top. And what that will do is it will cancel with my 4x on the bottom to make it a 2. But I can't just stick a 2 on. I have to kind of balance that. So I'm going to also multiply by a half. Okay, so what this does is the half and the 2 are going to cancel each other. But here are the 2 and the 4. I'm going to cancel and make that a 2. All right, so now I know that this part is going to equal 1. So my final answer is 1/2 times 1, which is 1/2. All right, today we are learning about integrals. So let's start number 1. We're going to do sort of a review problem from 3.12. Find the general antiderivative of f of x equals 3 over radical x plus sine of 2x. So the first thing I know I want to do is just rewrite this as 3x to the negative 1/2. And now I'm going to follow my antiderivative rules that we learned yesterday. So I'm going to have capital F of x equals, I know I want to add 1 to my negative 1/2. So that's going to give me a positive 1/2. And then I want to divide by the 1/2 that I just put up there. Put that on the bottom. Okay, next I have sine of 2x. So I'm thinking, what would have positive sine as its derivative? And the answer is negative cosine 2x. And then since it has a 2 in there, I want to have a 1/2 to balance that, plus c. Okay, I'm going to rewrite this one more time. And the reason why is that this first thing here, when I divide by a half, I'm really timesing by 2. So that's 6x to the 1/2 minus 1/2 cosine 2x plus c. And remember, the plus c is just to account for any constants that might have been erased when the derivative was taken. All right, so let's look at number 2. It says a hot air balloon ascending at the rate of 12 feet per second is at a height 80 feet above the ground. When a package is dropped, how long does it take the package to reach the ground? Okay, so we have a couple of things here. First of all, they told us that dv dt is negative 32. Okay, so it's going to be really important on this one to remember the relationship between position and velocity. So if you recall, when we first started learning about rate of change, we learned that we had 3 things that had a relationship. So we have acceleration, we have velocity, and we have position. And we know that the derivative of position is velocity, and the derivative of velocity is acceleration. Okay, so now let's think about this example. They told us that dv dt is negative 32. So if I want to find the velocity, I actually have to do the antiderivative of this. Okay, so I'm going to undo my derivative. Here I have my derivative, dv dt. I'm going to undo that derivative to get v, the velocity. And so if I just have a constant here, that means that my antiderivative would be negative 32t. Okay, so I'm adding that variable onto it. Okay, and then you always want to check. So if I did the derivative of this, negative 32t plus a constant, what would I get? Negative 32. Okay, that's good. All right, and so now we're actually going to use this fact right here. They told us that the velocity at the time of 0, so when this whole thing starts, our time is 0, kind of when we start thinking about the problem, our velocity is 12. So this actually gives us a t, 0, and a v, 12. So we're going to plug those in, and what that's going to do is it's going to allow us to solve for the constant. So in this case, our constant is 12. Okay, so now we have an actual full equation. Velocity equals negative 32t plus 12. Okay, so we have our velocity, and remember, if you have the velocity, that's really the derivative of position. Okay, so another way of thinking about velocity is it's the derivative of position. And remember, we use the letter s for position. Okay, so if I want to find the position, I need to do the antiderivative of ds dt. Okay, so I'm going to do the integral or the antiderivative of ds dt to get s, which is position. Okay, so we would have negative 32. We're going to add 1 to the exponent on the t. Right now it's a 1. We're going to make it a 2. And then we want to divide by 2 to counterbalance that. Plus 12t. Okay, I'm adding a t onto the constant. And then plus c for the unknown constant that could have already been on that equation when I did the derivative. All right, so the second thing I want to use now to find the c that I don't know is that at the start of this problem, when the balloon was ascending at a rate of 12 feet per second, it was at a height of 80 feet. So they're actually telling us the position, 80, at the time of 0. So I'm going to plug in the 0 for the t, and that means that my constant on this second one right here is going to be 80. Okay, so now I have a nice position equation. S equals negative 16t squared plus 12t plus 80. I'm gonna go ahead and solve that equal to 0 because I want it to reach the ground, so I want the position to be 0. So I'm gonna make this equal to 0. And then I do need to use Pythagorean, or not Pythagorean, quadratic formula. So I'm gonna write that quadratic formula. Okay, I am not gonna work out the quadratic formula right now. I just am gonna tell you the answers. If you'd like to work it out on your own notes for your own satisfaction, that would be fine. So we get two answers here. We get negative 1.89 and we get 2.64. Obviously, I'm going to reject the negative because we're talking about time. So I'm going to keep the positive. Okay, so here's our definition. The collection of all antiderivatives of f is called the indefinite integral of f with respect to x and is denoted by, and so here we have our integral symbol. Okay, it's called an indefinite integral because we're doing all the possible integrals, and that just means we're going to have that plus c at the end that gives us all the multiple different ways that this could have been written. Okay, so here we have our integral sign. And f, the function f is the integrand, and x is the variable of integration. Okay, so let's try number 3. We're going to do an integral. It's exactly what we did yesterday. Okay, it's just a different word for it. We're calling it an integral instead of an antiderivative. It's the same thing. All right, so let's go ahead and do our integral here. So remember, we add 1 to our exponent and we divide by the new exponent that we have. Next we have 2x squared over 2 and 5x plus c. We want to cancel the 2's, so final answer would be x cubed over 3. You could write it as 1/3 x cubed if you wanted, minus x squared plus 5x plus c. All right, so your homework is to practice some integrals. Remember, it's the same thing as antiderivatives, so you're basically doing what you did on 3.12. We're just using the integral sign.